Hello, my name is Allison Gray, and I am an assistant professor in the School of Oceanography at the University of Washington. Over the next few minutes, I'm going to tell you just a little bit about the air-sea carbon flux data and products. Understanding ocean-atmosphere carbon exchange is critically important, as the ocean plays a fundamental role in the global carbon cycle. As shown in this schematic from Friedingstein et al. 2020, the ocean has taken up approximately 25% of the anthropogenic carbon dioxide that's been released into the atmosphere over the past decade. This uptake of anthropogenic carbon, however, is superimposed on a natural exchange of CO2 between the ocean and the atmosphere that is roughly 30 times larger and carries significant uncertainties. So, having CO2 flux data and products that are findable, accessible, interoperable, and reusable is of primary importance for predicting future changes in the global climate. The currently existing CO2 flux data set that is most widely used is the Surface Ocean CO2 Atlas, or SOCAT, which has embraced fair data principles, much to the advantage of the wider scientific community. SOCAT is a collection of high-quality surface ocean and atmosphere PCO2 measurements, largely from underway ships and some moorings, and it provides the foundation for constructing gridded estimates of ocean PCO2 and air-sea flux, as shown in this schematic from Wanikoff et al. 2019. Recent advances in currently existing data sets in data products include combining coastal and open ocean PCO2 data, the results of which are shown in this plot on the right, and standardizing fluxes from different PCO2 data products in order to facilitate comparison and a better understanding of the mapping methodologies. Despite the incredible and monumental efforts that have gone into creating and maintaining SOCAT and its derived products, large uncertainties still exist, particularly in the Southern Hemisphere where data coverage is poor. In light of this, Hawk et al. In their recent paper on the consistency and challenges in the ocean carbon sink estimate for the global carbon budget made the following two recommendations. Of primary importance is to extend and sustain the high quality surface ocean carbon observing network that makes up the SOCAT database. Secondly, we should work towards including data from novel observation platforms, such as biogeochemical Argo floats and sail drones into our mapped data products. Sail drones, such as the one depicted in the schematic on the left from Sutton et al. 2021, and other uncrewed surface vehicles can provide autonomous high-frequency measurements of CO2 in both seawater and air. Furthermore, data from biogeochemical Argo floats that are equipped with pH sensors, the current distribution of which is shown on the left, can be used to calculate ocean PCO2. Although these calculated PCO2 estimates have a greater uncertainty than the direct measurements, incorporating such data into our mapped data products with appropriate uncertainties will greatly expand our data coverage in both space and time. As we work to incorporate data from new platforms, we should strive to ensure that the data and products follow the fair data principles as thoroughly and early as possible. Thank you for your attention.